Stop recording. Button.
We talked about a function. A function is a rule. And so when you have a function, you are defining the rule which assigns a given value x to another, which is y. And this is defined as the f of x. We talked about how the f of x can be done by thinking of it as a mapping. We can think of it as a machine between input and output. We can evaluate it by simply assigning, according to the rule, the different values. And as a result, this produces a value that we obtain. We did not, I asked you to work through what? Through 42 in your exercises, or you may have gone beyond those, but I did not talk about the difference quotient. The difference quotient is used later in calculus, and it is a way of defining the limits of a particular value. So the difference quotient is something that you will see again, and this is when it first comes up. And it's defined as the f of a minus, the f of a plus h minus the f of a divided by h. This is the difference quotient.
What page is that?
This is on page 157. Now, the difference quotient is just a net change. We found the net change between two values. But the, what? Oh, okay. Is that everybody seeing that? A little more? There we go, okay. I'm trying to make it bigger, so I'm gonna have to figure out where you can see it.
Yeah, it's big. Yeah.
Now, this represents the difference quotient. Should I go back and work with some net change problems first? Okay. I turn the paper this way. Is this better for everybody? Can you see better on this one? Net change, could we write something? Net change. Net change represents the function at B minus the function at A. So if you were trying to find how a function changes between two values, if you are given a function such as the f of x is equal to 3x minus 2, and you want to know from 1 to 5. Is that all on there? Is it better when the paper is this one? Okay. Now, if this is the function and we wanna find the net change, and we consider this to be the first point and this to be the second point, then what we do is we find the f of 5 minus the f of 1. Now, the f of 5 is equal to 3 times 5 minus 2, and the f of 1 is equal to 3 times 1 minus 2. So the f of 5 minus the f of 1 would be equal to 3 times 5 minus 2 minus 3 times 1 minus 2. 15 minus 2 minus 3 minus 1. 3 minus 2 is 1. So we have 15 minus 2 minus 1. So that would be equal to 13. Which way? Up. Okay, there we go. Up. This is what net change represents. Net change is just taking the two values and finding out what the value of the difference between those would be. Now, if you want to find the difference quotient between two, this seems to always be a problem because they substitute the difference quotient is f of a plus h minus the f of a divided by h. Now, if the function is,
I think the projector's frozen.
what,
I think the projector's frozen.
Rosen?
Yeah.
Well, before you go to that, so you ended up with 13, 15 minus 2
Probably
minus
12.
1.
Uh-huh.
So that's 15 minus 3.
Is that 12? Did I
Yeah.
write down the wrong thing?
No, I'm trying to figure it out.
15 minus 2
Minus 1.
is supposed to be 12.
Okay.
There it goes.
So if f of x is equal to 5 minus 2x. What you are doing when you find the difference quotient is you are replacing x with first f of a plus h and then f of a. So what you do is you find f of a would be equal to 5 minus 2a. F of a plus h is equal to 5 minus 2 times a plus h. Then you take f of h, so you have 5 minus 2 times a plus h minus 5 minus 2a over h. This would be 5 minus 2a minus 2h minus 5 plus 2a over h. Minus 2a and plus 2a are eliminated. 5 and minus 5 are eliminated. So this is equal to minus 2h over h. H's are eliminated, so this is equal to 2. Does everybody see all of that? Now, that's what you have to do when you are finding a difference quotient. This begins the problems 43 through 50. Does anybody have any questions about doing any of those problems? Now, the next thing we want to talk about is the domain. Now, the domain of a function is limited by two important facts. The first fact is the denominator can never be 0. If you have a rational expression of a real number, this is when you have a rational expression of a real number. The other point that must be remembered is you cannot take the square root of a negative number. So that means that any function must be greater than 0. Now, it will become necessary sometimes to use some of the techniques that you just finished doing, where you had to make a chart, find the positive and value of those to find out where the problem had a real answer, because we are talking about real, rational answers. So when you are asked to find the domain of a function, it is always assumed that these two rules, if you would, are going to be followed. That the answer, the denominator, can never be 0, and you don't have any kind of square root of a negative number. So if you are asked to find the function of a domain, it comes down to checking these two situations. So if you are asked to find, if you're given the function f of x is equal to 1 over x minus 3, which one of these do you have to check to find the domain? The denominator. So what you have to do is you have to say x minus 3 is equal to 0, x is equal to 3. So that means that the answer is what? all real numbers except 3.
Say that one more time. What did you say?
Okay, you have to check the denominator. And you find out that x is equal to 3. When x is equal to 3, this function would not exist because the denominator would be 0. So the answer would be all real numbers except 0. I mean,
It's
all
3.
real numbers except 3. Now, how would you write that? There's a couple of options. You can use the technique called set theory, which is done like this. It's a set of x's such that x is not equal to 3. That's one. This is called set theory.
You wrote that up so we can see it.
You can also write it in our interval notation, which would mean what? How would you write this and leave 3 out?
Well, circle out on the line, right?
Okay, you could write it this way. You could write parentheses, negative infinity, up to, but not including 3, union with what? 3 to positive infinity. That would leave 3 out. Both of these notations say the same thing. X can't be 3. So again, when you're trying to find the domain of a function, you are going to check both of these situations. All right, let's say that we had this problem. Let's say that we had the f of x is equal to 1 over 3x minus 6. All right, what would we have to check? The denominator. So we would say 3x minus 6 is equal to 0. 3x is equal to 6. X is equal to 2. So that means that the answer, the domain, would be a set of all x's except x equal to 2. X cannot equal 2.
What would that look like in terms of a graph, a line? Would it be just a
It'd be like
circle
what?
around 2 and arrows in both other
Mhm.
directions, opposite
Yeah.
directions?
Could be any value except the number 2. All right, now let's do one that f of x is equal to x plus 2 over x squared minus 1. Now how would this present itself? This would mean we would need to factor this, x plus 2 over x plus 1 and x minus 1. So we would have 2 values to consider. X plus 1 is equal to 0. X is equal to negative 1. And then x minus 1 is equal to 0. X would be equal to 1. So x could not be either 1 or negative. Why would we not be concerned with the factor in the numerator? Or are we concerned with the factor in there? Because we don't have a possibility of getting a zero. If the zero is in the numerator, that's not gonna make the ultimate function undefined.
So is your answer, the one at the top, is your answer x is not equal to?
Yes,
Okay.
it would be all real numbers except x is not equal to.
So in these problems, we only work out what's in the denominator.
Yes,
Okay.
yes. In order to find the domain, you have to consider the two situations where the problem would not exist. Yes.
How would you write it in set theory?
In set theory, it would be a set of x's such that this vertical line means such that x is not equal to -1 or 1. If you wrote it in interval notation, what would you have to do? You have open infinity, negative infinity up to what? -1, don't include 1, union with what? -1 to what? 1, don't include that. But then you'd have to have a third section where you would have what? 1 to infinity. That leaves out -1 and it leaves out 1. And graphically, what would we have? -1 and 1. We would have what? Circles around this. This would be here, here, and here. Does include all those. It would just be, the graph would just have those holes in it. Yes.
So, like, let's say we have a quiz, does it matter which way to be writing?
No, it does not. If it's asked in, this is called set notation, or set theory. And this is called interval notation. It's two ways to write the same thing. Now, this is all I want to do today because I want you to be sure you understand the difference quotient and the idea of finding the domain. So the only thing you are responsible for in problems are from 42 through 72 that are on page 157. And I want you to try your hand at doing these and writing the notation in this folder. Then on Thursday, we'll go into section 2.2, which is graphs.
You got a
And
quiz?
what-
You got a quiz Thursday?
the quiz on this will be next Tuesday.
Okay.
Trying to get this so that there's always a day in between. You have had questions.
Stop camera chooser. Stop recording.